Hey guys, it's Mr. Hammond again. Welcome to the whiteboard. Today it's going to be quick adding, subtracting decimals, and then finally multiplication. Adding and subtracting, very easy. You line up your decimals and then you just do the action that's required. First question, 7 plus 4, we know that is 11. First one, you carry the second. 2 plus 3 is 5 with an additional 1. We know that it's 6. That answer is 6.1, very simple. Here we have 4 decimal 63 plus 7 decimal 5. Our decimals are lined up, but we are missing a number, 7.5. 7 decimal 5 is the same as 7 decimal 50. So now we have everything lined up, ready to go. Our 100th place value is lined up. 3 plus 0 is 3. 6 plus 5 is 11. We carry the 1. And 7 plus 4 is 11. Plus that additional 1 puts us at 12. And carry that decimal all the way down. Subtraction, same idea. All right, just line up the decimals and follow suit. 9 minus 1 is 8. 1 minus 2, can't do it. So what we do is we borrow from the neighbor. And this gets us to 11. 11 subtract 2 is 9. Carry the decimal down. Simple as that. Same thing here that we did earlier, 9.4. Well, we know that's going to be the same as 9.40, 9 decimal 40. 0 take away 5, can't do it. What we do, borrow from the neighbor. This becomes 10. 10 subtract 5 is 5. 3 subtract 2 is 1. 9 subtract 7 is 2. Carry that decimal down. Adding, subtracting, easy. Multiplication gets a little bit complex because what we have to do to start is ignore the decimal. All right? So just for show, we're going to erase the decimal to have 2-digit multiplication. Okay? 2 times 6, we know is 12. Carry it. 2 times 2 is 4 plus 1, that's 5. Now, because we're going to our tens, now that it's an imaginary non-decimal number, we need to add the 0 to start our 10th place value down here. 1 times 6 is 6, 1 times 2 is 2. We add this up, we get a number of 2. 5 plus 6 is 11. 3, because it's 2 with that additional 1. Now, that's not a decimal. And if we go back and we put the decimals where they originally were, and we just have a look at it, this number should be close to 3. Right? If we round up to 2, that's a 3 times 1. If we estimate it, we're looking at an approximate number of 3. We know it's not going to be 312. Right? That's just too big. So what I like to do is I like to look at how many numbers we have behind the decimals. Well, I have one number here and another number there. That's 2 numbers behind the decimal, which means my decimal, which starts here, will have to move once, twice, to give me a number of 3.12. You're moving in that number as it goes along. Last one to try it out. Same thing we're going to do. We're going to ignore the decimals for now. All right. Now it's a 3-digit multiplying 2-digit. 6 times 1 is 6. 6 times 5 is 30. 6 times 4 is 24. Plus 3, that gives us a magic number of 27. Because we're going to the tens again, we're going to add the 0. 2 times 1 is 2. 2 times 5 is 10. We're going to carry that 1 up. 2 times 4 is 8. Plus that 1 gives us 9. Then we add everything. We have a 6, 2, 7, and 11. Now we know the number is not going to be 11,726. If we add the decimals back in, how many numbers do we have behind the decimal? Well, in our first number, we have 2. the 5 and the 1. And the second one, we have 1, well, the 6. So how many total numbers is that behind the decimal? 3, which means we need to move the decimal to have 3 numbers behind it. And if the decimal starts here, we're moving 1, 2, 3, which gives us 11.726 thousandths. All right. That's it for this. This is pretty quick and easy. Keep an eye out for any new videos coming. Study hard, stay out of trouble, and happy learning.